This video demonstrates how to evaluate integrals involving nested radicals using substitution methods. We'll substitute u equals the square root of 1 plus 1 over x. This gives us x equals 1 over u squared minus 1, and dx equals negative 2u over u squared minus 1 squared du. The integral becomes negative 2u squared over u squared minus 1 squared. We then decompose using partial fractions and integrate. Let's work through it on the diagram. How do you integrate the square root of 1 plus 1 over x? The nested fraction under the radical makes direct methods impossible. Most students get stuck because no standard formula applies. The key insight is a substitution that clears the entire radical at once. Question: find the integral of the square root of 1 plus 1 over x dx. Step 1. We substitute u equals the square root of 1 plus 1 over x to remove the radical entirely. Squaring both sides, u squared equals 1 plus 1 over x. So 1 over x equals u squared minus 1. Therefore, x equals 1 over u squared minus 1. Differentiating, dx equals negative 2u over u squared minus 1 squared du. Now let's substitute everything into the integral. Step 2. We substitute u, x, and dx into the integral and simplify. The integral becomes u times negative 2u over u squared minus 1 squared du, which simplifies to negative 2 times the integral of u squared over u squared minus 1 squared. The denominator factors as u minus 1 times u plus 1, all squared. We decompose into partial fractions with constants a, b, c, and d. Let's solve for the coefficients and integrate each term. Step 3. We find the coefficients by substituting convenient values of u, then integrate each fraction. Setting u equals 1 gives b equals 1/4. Setting u equals negative 1 gives d equals 1/4. Comparing remaining coefficients, a equals 1/2 and c equals negative 1/2. Integrating each term and multiplying by negative 2, we get negative natural log of u minus 1 plus natural log of u plus 1 plus 1/2 times 1 over u minus 1 minus 1 over u plus 1. This simplifies to natural log of the absolute value of u plus 1 over u minus 1 plus u over u squared minus 1 plus c. Finally, substituting back u equals the square root of 1 plus 1 over x, and noting that u over u squared minus 1 equals x times u, we get our answer, natural log of the absolute value of square root of 1 plus 1 over x plus 1 over square root of 1 plus 1 over x minus 1 plus x times the square root of 1 plus 1 over x plus c. Now you can handle integrals with nested radicals and fractions. Substitute to clear the radical, then use partial fractions on the resulting rational function. The final answer combines a logarithmic term with an algebraic term, all expressed back in terms of x. A powerful technique for tough integrals.